In balloon question, what we did? A balloon was going up. Certain time after, he leave a stone, right? A stone or ball or whatever. Okay. Same thing here. This is a balloon. Okay. And he went up. Okay. Went up. After this, when he was at how much height? 45 meter. How much height? 45 meter. After that, what he did? He left a parachute, like a person jumped from it. Okay. Jumped with a zero velocity, we have to assume, because he didn't give any horizontal velocity or nothing. Okay. To jump from it. So we can say when he will jump out of this balloon, what will be his velocity? That we can say according to the stone dropped, right? What is the velocity? 0. Same as the balloon, right? No? Let's say when you are going in the lift, okay, this pen is in your hand, right? Lift is going up with 10 meter per second, okay? So this pen is also going with 10 meter per second upward, right? So 10 meter per second, 10 meter per second going continuously together. Suddenly I leave him, right? So earlier I was supporting him to go 10 meter per second. Now I left him. But speed it will have 10 meter per second only up. But now it is under the influence of gravity, right? So going up with 10 meter per second and having an influence of gravity, then like this, right? So here when he is at 45 meter, he left from the upward going balloon, right? So he will have the velocity same as the balloon, which is how much? 10 meter per second. This is the initial situation of that person, okay? Now after 3 seconds, he opens the parachute. After 3 seconds, he opens the parachute and constantly deaccelerates with a rate of 5 meter per second square. Okay. So you first check after 3 seconds where he is. Basically, wait for a second. He opens his parachute and deaccelerates at a constant rate of 5 meter per second square. What was the height of the parachute above the ground when he opened his parachute? Okay. So this constant rate of 5 meter per second square we no need to use. Okay. See what will happen. After 3 seconds, what will be the motion we have to find out. Okay. So I told you this thing that time of flight you can calculate. That is a different thing. Okay. But here where he will be at t equal to 3. So first of all calculate what is the velocity at t equal to 3. So a particle started from here. I know motion will be like this, right? Originally it should be like this if he doesn't open the parachute, right? At t equal to 3 from here, where it will be? So let's say at t equal to 3 he is at certain position, let's say here, with a velocity v. Can we find out v? What we know between these 2 points? We know the u, we know the gravity, and we know the time, 3 seconds, right? From here to here, a general position, 3 seconds, right? 3 things we know. Can we get the v? What is? V equals to u, that is 10 plus acceleration minus 10 into time, 3 seconds. How much? How much? Minus 20 meter per second. Minus 20 meter per second means what? Going down. Means the position I assumed is wrong actually. I have to assume him going down. Okay. And in this also there is little bit extra thing. See, if you understand when I taught you the projectile from a height, that time I told you should draw a line here like this, right? This projectile is ground to ground. This motion is ground to ground, right? Okay. So at this point, what is the velocity? Downward 10. Okay, exactly. Okay. This going up and this going down symmetrical, as I told yesterday also, one question came in that. Okay. So till here 10 only, he need 20. Okay. So somewhere here already he reached 20 meter per second. Okay. We can find out the location also. How will find out location? Displacement na. This is 45 meter height. Location means basically displacement. So from here, let's say x displacement. How much displacement? X. This motion is not there. We can say this displacement is x downward, right? So between these 2 points, what you know? Let's say 20 meter you don't know. Okay. 20 meter per second you don't know. Initial velocity you know. gravity you know, and you know the time 3 seconds, right? So what is the x displacement? How we will calculate? S equals to ut plus half ut square. So x value will come automatically negative if it is downward displacement, right? And if it is a positive, it will come. Displacement vector means initial point and final point joining. So if it is coming positive means displacement, he is above this point, and if it is coming negative means it is below this point, right? So this x will come automatically negative. So s is equals to ut. U is what? 10 into time 3 seconds plus half into g minus 10, because g vector is downward, okay, into 3 square. How much is this? Minus 15. Minus 15. Minus 15. Agree? Minus 15. What happened? Huh? What happened? Everyone got sad? See, the problem is that you are, if I tell you, if your basics are strong now, then you can do, okay. And IIT, what happens is that they solve mathematics every day, okay. You solve botany, zoology every day, solve what you read, okay. So you have a mentality of remembering everything, okay. That can give the answers of NEET 2024. I can guarantee you can have all the answers of NEET 2024, and most of you, the people here, remember also all the answers till NEET 2024. Whatever PYQs came, you know all the PYQs. I know that. Line by line, if I give, you will tick the answer directly without solving. Okay, I know you people. But that you can't do with 2025 paper. Okay, not even a single question you will be able to touch. And why most of the people not able to do? You are not alone that is not able to do. Most of the people didn't do. Why? Because every academy is teaching that manner only. That remember this formula, remember this formula, remember this formula. Okay. Even one single, see, I have understanding, that's why I am doing. But I am trying to tell you the same understanding in every single question. Right? Then where is the problem? After a certain level of questions, there are no type of questions. Right? But still, things can change there, right? So we have to just understand which direction acceleration acting, which direction velocity is going, what is should be the motion according to these values, right? Correct? That's it. Okay. Both the motion in straight line question you can't do with this concept. With any formula you can't do. Simple logic is that. Try to understand this. So x came how much? Minus 15 meter. Okay. So minus 15 means here. Okay. After coming here, he is opening the parachute, okay, and deceleration is how much? Minus 5. Means as soon as he opened the parachute, okay, gravity was downward, right? But he opened the parachute, then overall upward acceleration became 5 meters per second square, okay, and he landed on the ground with certain velocity or not velocity, doesn't matter, okay. He's just asking where he opened the parachute, right? So he opened here, right? From here, how much we find out x? 15. So this is how much? 45 minus 15, 30. That's your answer. Okay. Doesn't matter with what velocity is hitting the ground. Okay. If he have asked me, that also we can solve. That overall when you open the parachute, you are deaccelerating. Now you are not going faster. You are slowing down. Okay. So you are with 20 meter per second. And what is the gap remaining? 30 meter. And what is the acceleration? Upward 5. Right. So going with 20 meter per second. What will be the final velocity he will hit the ground? Can we find out? If needed. Can you find out? Initial velocity I know minus 20. Acceleration I know plus 5. And distance I know minus 30. Right? This is initial, this is final. So downward displacement. Minus 30. Which equation? So V square, we want to know U square minus 20 square plus 2 acceleration plus 5 and displacement minus 30. V square equal to how much? 400. This is minus 5 to the 10, 300. How much? 100 means V equal to 10 meter per second. Still, he is going with this retardation. Still, he will hit the ground with 10 meter per second. Very high velocity actually. Okay. Because you don't realize the velocities in meter per second. because generally you see the bikes, cars, those are in kilometer per hour, right? So if you convert this in kilometer per hour, it will be 18 by 5 factor. 3 times around 3, 4, 30 to 40 kilometer per hour. Okay, so that's all. So this we don't need. Okay, this is the original equation. So understanding is what the balloon question. Okay, from there. Anything is left from any body which is moving. The kart question we did, right? Particle was thrown upward, but kart velocity also he got. Okay, that's same thing here. He's solving this question only ahead. Okay. So he's asking in 73. In above question, how far is the parachute from the balloon at t equal to 3? Okay. So what we understand is parachute at t equal to 3 he came here, right? Okay, right? From this position where he left him, right? From there t equal to 3 he came 15 meter down. Okay. But in this 3 seconds, this parachute is also going up, right? So he is going with what velocity? Parachute? Sorry, parachute not, balloon. Balloon is going with what velocity? 10 meter per second. So in 3 seconds, how much he went above? S equals to ut. Acceleration is not there. He's not having any acceleration, right? S equals to ut. So how much? 30 meter, right? So from this point, balloon is 30 meter above, and from parachute is, the person is 15 meter down. So how much is the gap? 45, right? That he is saying. How far is the parachutist from the balloon? 45. Got it? From this position where he left him, from there, this balloon is 30 meter above, and this person is, as we saw, 15 meter below. Got it? So 45 is the answer. Now which formula to be applied in this? 74. With what velocity does the parachute hit the ground? As we saw, 10 meter per second. Okay, that's all. I didn't know it is a paragraph question. In above question, after how long does the parachutist hit the ground after his exit from the balloon? Okay, see, exit from the balloon. So what we see here is, this pen is visible, right? So from this point A, let's mark this, and here he reached B point in how many seconds? 3 seconds under the free fall, means under the gravity, right? Free fall means under the gravity, okay? That you remember. So here A to B under the gravity, 3 seconds he took, okay? And here to here is motion, their acceleration is changed, right? So don't apply the equation of motion here to here directly. Why? Because in this motion there is acceleration downward g. And in this region, how much is the acceleration? 5. Retardation 5 means what? Retardation means what? Opposite to the velocity, that's it. Velocity is positive side, negative side, doesn't matter. Opposite to the velocity means that is known as retardation, okay? So 5 above. So here to here, how much time it took to go 30 meter? Everything you know here. Initial velocity 20, final velocity 10, acceleration 30 meter. Which equation? V equals to u plus at apply, because everything you know, okay? So V is what? Downward 10, na? So minus 10. Apply with the downward taking negative, no problem, okay? Minus 10 is equals to initial velocity minus 20 plus acceleration plus 5, right, into time t, that we have to answer, right, from here to here how much time. How much it took? 20 minus 10, 10 by 5, 2 seconds, right? So he is asking when he left the balloon, okay, till the time he land, how much time it took. So here to here 3 seconds and here to here 2 seconds, total 5 seconds, okay. If you are applying equation of motion between those 2 points, the only condition is that acceleration should be constant, okay. Here to here we can't apply. Why? Because acceleration is not same. Here to here acceleration g, here to here acceleration plus 5 above, okay. Got the point? That's it. 76 doubt. A ball is thrown vertically upward from a top of a tower with a velocity 10 meter per second. If the ball falls on the ground after 5 seconds, the height of the tower is. Now this is formula based. Okay. This we can say, he asked, if I ask you a particle thrown upward from a height, what is the time of flight of that particle, right? So he gave you the time of flight. He said that initial velocity particle is thrown with u, okay, from a capital H height. Can you solve for time of flight of this question? How we will solve? Which equation you will apply? What we know that you think, right? So between what points you need the time? First tell me that thing. This point and this point, right? Till here time, how much it took, right now? What you know? She will answer. Initial velocity, acceleration, h, height of the building we know, let's say. So which equation you will apply? Height of the building he asked, I know. But wait, let's say height of the building you know the initial velocity. A particle projected from a h height, the initial velocity u. How much time it will take? What things you know in this situation? U, h and g. Which equation you will apply? Silent everyone. V square equals to u square plus 2as. To get the time. I need the time. V equals to V. How you know the velocity here? V we don't know now. Ut plus half at. Okay, this way of thinking correct. See, we have three equations. V equals to u plus at. S equals to ut plus half at square. And V square equals to u square plus 2as. Okay. Between these 2 points, I know the initial velocity, I know the displacement, and I know the acceleration. Now 3 things I know. I have to use those 3 things and I have to find out the time. Okay. I will try. She tried with the first equation. First equation V is there. We don't know the final right? So I can't use that. Got it? Then she went for the third equation. Still V is there. So still we can't go because I need the time, right? There is a possibility you have to get the V and then you put in that other equation. Okay, that is possible. That is good idea. But still we will try to find out, at least check once all the 3 equations that we can find out other value or not. So in this, the second equation, if we check, I know the displacement, I know the initial velocity, I know the acceleration. So I can get the time. Okay. Here the question is reverse. He gave you the time and he asked you the h. Okay. That is more easier because this is a quadratic in t. Okay, so either you have to solve quadratic, but he gave you the t and he asked you the displacement. So how we will apply originally in the concept, how I taught you that from this point to this point, initial velocity upward, right? What is the displacement, upward or downward? This is initial point, na? And this is final point. So displacement vector will be from initial to final like this, right? Displacement vector downward. So you have to put it minus h. Downward, all the quantities downward will be negative, upward quantity is positive. So second equation, it will come minus h is equals to ut. U is upward, so positive. T plus half into acceleration downward, so minus g into t square. Okay. In this h he asked and t he gave. So put the values, that's it. Okay. Now this question was doable. A juggler maintains 78. Okay. A particle is released from rest from a tower of height 3h. The ratio of the times of fall equal heights h is t1 is to t2 is to t3 is from rest from a tower of height 3h. Okay. So the question is something like this, that tower height is how much? 3h. Okay. So particle dropped, released na? Release means released from rest, dropped. V equals to 0. Okay. So he is saying that h height, then next h height, and then next h height. Okay. In this interval, it took t1 time. In this interval, it took t2 time, and this interval took t3 time. Okay. I want the ratio of t1 is to t2 is to t3. That's it. Okay. So how we will solve? What we can solve, that much do. Okay. First thing is that from here to here, can we get the t1 in terms of h? Basically, if you get the t1, t2, t3 in terms of h and you put the value, h will cancel out and answer will come. This much only I can think for now, right? that I have to get the T1 in terms of something. Okay. So what I know, downward this point and this point, time I want to know. What I know, initial velocity, I know the h, displacement down, and I know the gravity. Can we get the time? Which equation? S equals to ut plus half at square. So displacement is how much? Minus h. Downward na? This is initial, this is final. Is equals to ut. Ut is what? 0 plus half acceleration minus g into t1 square. So t1 square, let's write down t1 square only. How much is that? 2h by g. Okay? Agree? Okay. That's it. So now, from here to here, you write down, but let's say you didn't thought this thing. You write down from here to here, we have to find out time. So here to time to t2, right? Okay? So what you will write down? In between these 2 points, what you know? Displacement and gravity. 2 things. Okay? Then how you will write down? You can't write. Okay? But if I write down from here to here, right? Time taken is t1 plus t2. So I can get the t1 plus t2. T1 I know. So I will get the t2. Right? So how will I get? Here to here displacement 2h. So minus 2h is equals to ut0. Here ut got 0. Here I didn't know the velocity, right? So that is the good thing about this point. ut0 half minus g into t1 plus t2 ka whole square. Remember one thing. If you see the pattern in all the questions, na, don't write down, I will give it. And you will see pattern in all the questions. Na, wherever there is a start from initial velocity 0, right? Any 2 points, instead of solving a random point and another next point, he is solving from here to last point only. Here to here you solve and here to here you solve. So that at least you will have advantage of this one variable 0. So whatever like u into t is there, that got 0. Okay, that is the advantage of taking this point as initial and any other point as final. Okay, if you see any of the question. Okay, so this came, right? So here, from here, let's get the t1 also. T1 is what? Under root 2h by g. From here, what we got? t1 plus t2. How much? Under root 4h by g. Okay, so t2 came what? Under root 4h by g minus t1 minus under root 2h by g. Okay, from here you can take under root h by g common, but okay, you can take. If you take under root 2h by g common means I taught you what is the meaning of common taking? Divide with that value. Divide and multiply. Division you take that side. So what will come? Root 2 minus 1. Okay. Here 1, 2 you keep and 1, 2 root 2 you take outside. That's how this will come root 2 minus 1. Okay. Next is what? From here to here directly apply. Okay. Total time of flight. So total t1 plus t2 plus t3 is what? Same 3h, right? Minus 3h. Minus 3h is equals to ut0 half minus g into plus t2 plus t3 whole square. Okay. So I can say t1 plus t2 plus t3 is what? Under root 6h by g. Okay. t1 plus t2 already you know. You can put the t1 t2 value, again cancel out. t1 plus t2 is this, right? Under root 4h by g. So t3 is what? Under root 6h by g minus under root 4h by g. Take the under root 2h by g common, because I am thinking that taking ratio under root 2h by g will get cancelled out, right? So if you take under root 2h by g common, what is remaining? Root 3 minus root 2. Actually this question also there. Already this ratios is solved. Okay. Question was like this. Root 1 is to root 2 minus root 1 is to root 3 minus root 2. Like this ratio is solved already. Okay, one question. The question is repeated, but it's okay. In the printed questions. Okay. So this came. Now t1 is to t2 is to t3. So t1 is what? Under root 2h by g. 2h by g. Then is to t2. T2 is what? Under root 2h by g root 2 minus 1 is to under root 2h by g root 3 minus root 2. So common factor cancel out. That is the meaning of taking ratio. So that's the answer here. 1 is to root 2 minus 1 is to root 3 minus root 2. Okay, got it? This will continue if this height is 4h, 5h like that. Okay.